Okay, good morning, ladies and gentlemen. This is day 3 of number types and properties. So, here's what we got going on. Now, I did teach you guys, I told you guys about a trick that you could probably use with the math frac. I've discovered that doesn't always work. Okay, so be careful with that trick because there comes times where it really doesn't work and it sends you down the wrong path. So I'm just going to teach you guys the rules real quick. So anytime you add a rational number plus a rational number, you get a rational number. Okay? Anytime you add an irrational number plus a rational number, that is always an irrational number. Okay? An irrational plus irrational is also always an irrational number. Okay? You can test that theory just by simply using your calculator. So square root of 2 plus the square root of 2 equals 2.828427125, okay? All right, there's no pattern there. It should be non-terminating. So for example, square root 2 is equal to 2.828427125, okay? No pattern, continues on, irrational number. All right, now going to when we're multiplying, okay, that's when we're adding rational and irrational numbers. When we're multiplying a rational times a rational equals a rational number. An irrational times a rational number is equal to an irrational number. And then an irrational number times an irrational number. Okay, this is the one I showed the other day. Sometimes it's rational and sometimes it's irrational. So if you take, for example, square root of 2 times square root of 2. Move the 2's both underneath the radical. You have to do the square root of 4, which is equal to 2. And you can test this by plugging that into your calculator. All right? Multiply square root 2 times square root 2, and you'll find that you get an answer of 2. And what's happening here is when you're multiplying with radicals, okay, you can move both radicals, or both numbers underneath the radical, multiply those together, in which case 2 times 2 is 4, and the square root of 4 is 2. So a rule of thumb is anytime you see something like this, where I'm multiplying two radicals, two numbers underneath a radical, where the number is the same here, okay, the radicals cancel out, and you're left with that number inside there, okay? So just keep all of that in mind. All right, for these next two problems, okay? So let's take a look. The teacher wrote the following set of numbers on the board. Explain why a plus b is irrational, b plus c is rational. Okay, so let's take a look at what these numbers here, or what we have for numbers. Now we have this number right here, square root of 20. So if you take the square root of 20, right, you get some nasty number, 4.472135955, okay, no pattern. All right, if you tried math fracking it, which I told you not to use that rule or use that trick, but if you do, it stays the same. Okay, so this can't be turned into a fraction. All right, so square root 20 is an irrational number. Okay, so let me write that in there, irrational. Okay, 2.5 is actually just the number 5 over 2. Okay, which 5 over 2 is a rational number. So 2.5 is rational. And again, you can see that it is terminating. All right, it just stops at 2.5. All right, and so That should be another indication that's a rational number. Now this one might not seem so obvious, okay, but square root of 225 is actually equal to 15, okay? 225 is one of our perfect squares. So this number, 15, is actually a rational number. So this is explaining why a plus b is irrational, but b plus c is rational. So let's think about this. So a plus b, so you would have 4.472135955 plus 2.5. Okay? When you add those two numbers up, you're going to get some irrational number. So let me add that in there, plus 2.5. Okay, so you get 6.972135955. Okay? No pattern. All right, our calculator doesn't show, but it continues on. Okay, it's non-terminating. So therefore, and plus, let's think about it. We have an irrational plus a rational should equal an irrational number. Okay, and so for the second one, we have b plus c. So we have 2.5 plus 15, which is equal to 17.5. And if you typed in 17.5 in your calculator and you math fract it, you would get 35 over 2, okay? Which can be represented as a fraction. So 17.5 is terminating, can be represented as a fraction. And also, let's not forget, okay, we have a rational plus a rational, which is equal to a rational number, okay? So that's what you should have for a reason there, okay? A rational plus a rational is equal to a rational number, and the irrational plus a rational number is equal to irrational. Okay, so if you look at the one down below, all right, let's just take a peek what these numbers are. So square root of 121, if you guys didn't recognize it before, is 11. So we got 11 minus the square root of 21. All right. Now, I'm going to move this down here. Okay. Subtraction is really just the adding of a negative number. Okay. Let's think about that negative number. This number here is rational, and this one here is irrational. So a rational plus an irrational number is equal to irrational number. So this one is out. Let's take a look at number 2. Okay, square root of 25 is one of our perfect squares, so it's 5 times square root of 50. Now 5, okay, I'm not going to solve that out here, but let's think about this. 5 is a rational number. Okay, and square root of 50 isn't one of our perfect squares, so that's rational times an irrational, which means we are going to get an irrational number. So 2 is out. Let's take a look at number 4. So we got 3 square root 5 plus 2 square root 5. Now let's take a look at this first number. So this is a rational number times an irrational number, which means this is irrational, which also means that this is irrational. So an irrational plus an irrational number is irrational. So 4 is out, so it has to be 3. And why does it have to be 3? Well, let's take a look. So you got square root of 36 with square root of 225. What's significant about those numbers? Well, 36. Square root of 36 is just 6, and square root of 225 is 15. And here we have a number being represented as a fraction. If you divide 6 by 15, okay, you get 0.4, which is terminating. So, therefore, number 12, 3, is your rational number. That expression results in a rational number. Okay, number 13. So Brittany is solving a quadratic equation. Her first step is shown below. All right, so here's our problem, and then here's our step 1. So it's our job to figure out what 2 properties did Brittany use to get to step 1. All right, so we're going to have to notice what is different between the problem and step 1. So if you look on the right, what's different, zoom in here, okay, what's different is she distributed that 3. Okay, so it's definitely the distributive property. And then on the left, if you notice, the 8 and the 10 have been switched. Okay, now we notice we didn't change the value of them. It's still negative 8 and negative 10x. They were just, they switched places. And that is called the commutative property. So what 2 properties did Brittany use to get to step 1? It would be 2 and 4, which is option 4. Okay. Number 14. An online company lets you download songs for 99 cents each after you have paid a $5 membership fee. So which domain would be most appropriate to calculate the cost to download songs? So when we're talking about domain, we're talking about X values. All right? And so, I mean, we could write out what the function looks like. Okay, so you pay 99 cents each after you paid a $5 membership. So our function would look something like this. It would be $5 plus 99 cents for every song you download. All right? Now, we all download songs, okay? When I download a song, do I just want to just download the song all the way to the bridge? Or cut out the last chorus? No, okay? When you download songs, you download the whole song, okay? Which means we're talking about whole numbers. So rational is out automatically. Okay? So, let's talk about what we have left. So we have whole numbers and we have integers. Okay, so let's look at the integers part, because integers got me questioning, because integers involve negative numbers, and we don't want negative numbers, and it says integers less than or equal to 0. Okay, so which means we want integers less than or equal to 0, which makes no sense. Why would we download songs less than or equal to 0? I mean, we would download any. So that one's out. So it has to be this one. And whole numbers less than or equal to 0 wouldn't make any sense. So whole numbers greater than or equal to 1. Okay? Now why does it say greater than or equal to 1? Because if you didn't download any songs, okay, well, you still have to pay $5. So snooze, you lose. All right? But you want to at least download one, because otherwise, what are you getting the membership for? Okay? So the answer to number 14, which domain would be the most appropriate to calculate the cost to download songs? Okay, we're talking about the X values, and we want whole numbers for X values. We want to download the whole song. Okay, number 15 is the sum of 3 times the square root of 2 and 4 times the square root of 2 rational or irrational. Explain your answer. Okay, so let's take a look at this first number. This first number is a rational times an irrational. And we got the same thing over here. Rational times an irrational. Now remember, when we got a rational times an irrational, well, that just means you get an irrational number. Which means we got an irrational number plus, because that's what it means to have a sum. So is the sum of an irrational number plus an irrational number rational or irrational? Explain your answer. The answer is irrational because the sum of 2 irrational numbers is irrational. Okay, by irrational, I mean it's non-terminating. Okay, it goes on, there's no pattern. Okay, so anytime you're adding two numbers like that, all right, it's always going to be irrational. Okay, so the sum of two irrational numbers, all right, that's the key part, the sum. So when we're talking about sum, we're talking about adding. Okay, so which expression results in a rational number? All right, so let's take a look through here. Let's start with this one over here, okay? Because we just talked about this one. We got an irrational number plus an irrational number. Let me zoom in here for you guys so you guys can see it better. Okay, so we got an irrational number plus an irrational number, which means that this is going to be some irrational number. In fact, it's actually going to be 2 square root 2. Okay, so this one is out. Here, we just saw this one, didn't we? Very close to it, square root of 3, or 3 square root 2 plus 2 square root 3. Okay, we also have an irrational number plus an irrational number. So therefore, that is going to equal an irrational number. So that one is out. So all we have left is these two over here. All right, now this first one, I'm sorry, the second one here, 2, okay, don't circle that one. I just want to talk about it. Okay, is a rational times the square root of 5, which is an irrational number, which means we are going to get an irrational number here. So that one is out as well. So this one is your answer. Now, we haven't really talked about simplifying radicals, okay? But if you were to plug this into your calculator, right, you would get, and so square root of 2, square root of 2 times the square root of 18. And you get 6. All right? So, this is an irrational number, and this is also an irrational number. Okay, but we got to remember that sometimes when you multiply two irrational numbers, that doesn't necessarily mean you get an irrational number. In this case, when we multiply these two numbers, we get a rational number of 6. Okay, so all else fails, anytime you're multiplying two irrational numbers, all right, anytime you're adding them, we know that they're both irrational, or they're going to be irrational. Okay, so anytime you're adding irrational numbers, always irrational. Anytime you add a rational number and an irrational, always irrational. Okay, same thing with multiplication. Rational times an irrational is always irrational. This is the only one you have to be careful of. Okay, sometimes an irrational times an irrational number ends up actually being a rational number. Okay? Easiest way to solve that sometimes, those guys, is just to plug that into your calculator. Okay, so if you plug in all of these into your calculator, the only one you would get a rational number for is number 1. So all else fails, just plug them in, all right? See what you get. And then if you get a nice whole number like we did here, then you know you found a rational number. Okay, switch the color up a little bit. All right, so when solving, p squared plus 5 equals 8p minus 7, Kate wrote p squared plus 12 equals 8p. All right, so we're trying to figure out what properties she used. So how she got from this side, okay, so how she got from here to there. Okay, so if you look, all right, what's different, all right, the 8p and the p squared haven't changed. What changed is there's no negative 7 on the right, and now 5 is turned into a plus 12. So what they did was they added 7 to both sides. And by doing so, 7's canceled on the left, and you got p squared plus 12 equals 8p. So what they did was they added 7 to both sides. So when you add something to both sides, you're adding something to both sides of the equal sign. All right, so you're keeping both sides equal, because let's not forget. So if I have a is equal to b, well then a plus 5 is equal to b plus 5, right? So that is the addition property of equality. Okay, so that is number 17. We added 7 to both sides. Okay, number 18. All right. This is a domain problem. All right, so a grocery store sells packages of beef. The function CW represents, or C of W represents the cost in dollars of a package of beef weighing W pounds. So the most appropriate domain for this function would be, okay? So let's think about how much beef can weigh, right? It can weigh nice integers, nice whole numbers, right? All right, but we don't want any negative numbers. So integers is out. Okay, and also when we say rational numbers, we can also talk about negative rational numbers, right? Negative 2 over 1 is a rational number. Negative 4/5 is a rational number. So we don't want anything like that. But we can talk about fractions, right? 4/5 of a pound, 2/3 of a pound, okay? Those are all decimal numbers. Right, so when you weigh stuff, I mean, most cases when we're weighing beef, it's never exact. You know what I mean? So it's never going to be, this beef weighs exactly 5 pounds every time. It depends on the cut. You know what I mean? So, that being said, right, I like 3 and 4 when it says the word positive, but we want to include more than just integers, okay? Because what about the beef that weighs, 12.8 pounds? You know what I mean? You want to make sure you're getting credit for that 0.8 pounds. I mean, that stuff ain't cheap. Right? So your answer has to be number 4. Positive rational numbers. Okay, so you have whole numbers. Right? So don't forget 2 over 1 is just equal to 2, so that's a whole number. All right, but we can represent it as a fraction as well. All right, so anyway, excuse me. That is number 18. Number 19. All right, so when solving the equation, 2x squared minus 7x is equal to 6 minus 2x squared minus 1. Evan wrote 2x squared minus 7x is equal to 6 minus 2x squared plus 2 as his first step. Which property justifies his step? All right, so all we're looking for is, again, what's different between this piece and this piece here. All right, so what it looks like is that the 2 was distributed in the parentheses. And so we're left with the distributive property of multiplication over subtraction. So that's number 19. Number 20. Okay, so 20's got a little bit of a trick in here. All right. That's why I mentioned earlier about my math frac button. That doesn't always work here. Okay, so let's just think about what the square root of 567 or 576 is. So if you take the square root of 576, okay, you get 24, which 24 is a rational number. Okay, now we're talking about the product, so which means we're going to multiply these two pieces together. So we got 24 times, I want everybody to take the square root of 684. Now we don't get a perfect square here, do we? We get 15339,366. Okay? Which is, since 684 isn't one of our perfect squares, this is an irrational number. And remember our rule, okay, irrational times an irrational is an irrational number. All right? Now, if you were to multiply these two pieces together, all right, and you hit the math frac button, okay, well, first if you multiply these two together, you would get this number right here, which is equal to, if you math frac it, which looks like a fraction to me, right? Okay, so that's why this math frac button isn't always the best trick. Because the answer here is an irrational number because one of the factors is irrational. Okay? And so that trick, the math frac, isn't always your friend here. Okay, because this is an irrational number. All right? What's the answer to number 20? It's irrational because one of the factors is irrational. Okay. Number 21. Okay. So state whether 7 minus the square root of 2 is rational or irrational. Explain your answer. Okay. So let's take a look. 7 is a rational number. Now don't forget, subtraction is just like adding a negative number. So in this case, we got a rational number plus the square root of negative 2 is an irrational number. So we got a rational plus an irrational, which is equal to an irrational number. Okay? So explain your answer. Plus an irrational number equals an irrational number. And that's all you have to say. Okay? All right. So number 22. A store sells self-serve frozen yogurt sundaes. The function CW represents, or CFW represents the cost in dollars of a sundae weighing so many ounces. An appropriate domain for the function would be. All right. So they always see these integers, rational numbers. All right. I'm seeing these non-negatives. That has to be it. Okay. Because when we include all the integers, we include negative numbers. And when we include all rational numbers, we also include the negative rational numbers as well. So those are out. Now, let's think about when we're weighing frozen yogurt. All right. I don't know about you guys, but, you know, I'm not very careful with my measurements. So as I'm pouring the yogurt into my dish, all right, I'm not like, oh, okay, that's about 4, you know, well, I don't know, 4 pounds. I don't know if that's a lot of yogurt. But anyway, so when you're weighing these things, it's not exact, okay? Just like with the meat, all right? When you're weighing the meat, it's not always exact, okay? We're not perfect, okay? So non-negative integers would have to be out and be non-negative rational numbers because we want to include decimal numbers as well when we're talking about weighing the frozen yogurt. Okay? So non-negative rational numbers is the correct answer for 22. 23, we're going to determine if the product of 3 square root 2 and 8 square root 18 is rational or irrational. Explain your answer. Okay? So, again, we haven't really discussed about factoring these rational or these radicals, factoring radicals, okay? But if you were to type this in your calculator, so if you went 3 square root 2 times 8 square root 18, okay, you would find that you get 144. Now what we have here is we have an irrational number times another irrational number. What you got to remember is that sometimes an irrational number times an irrational number doesn't always result in another irrational number. Okay? So an irrational times an irrational number doesn't always result in another irrational number. Okay? So in this case, these two numbers multiplied out equal 144. So therefore 144 is a rational number. Okay. So that's number 23. Number 24, the daily cost of production in a factory is calculated using this formula here, where X is the number of complete products manufactured. Which set of numbers best defines the domain of C of X? Okay. Now this isn't a great question because I feel like the answer. Oh, actually, I'm sorry. Different problem. This one's good. Okay. So which set of numbers best defines the domain of C of X? Okay. So I'm going to cancel out integers because, again, when we're talking about complete products, we're not talking about negative complete products. That doesn't make any sense. Okay, so we're looking at positive reals, positive rational numbers, and whole numbers. Okay, so when you say positive real numbers, we're including all types of real numbers. So we got whole, we got rational, we got irrational. Okay, we got natural, integers. Okay, whole boatload of different types of different number types. Okay, so we don't want to include all those. We don't want irrational numbers. We don't want rationals. Okay, we don't want integers. Okay, well, we do want integers. All right, but we just want the positive ones. So when it says positive real numbers, it's including all of those, and we don't want the rational or irrational. So that means we're going to cross out, irrational, or the rational numbers as well, right? Because when we're talking about complete products manufactured, we don't want to include fractions of a product. I mean, it says complete, okay, complete products, which means, okay, I like the fact that it says positive, but when you include all reals or rational numbers, we're talking about, irrational numbers, we're talking about decimal numbers, and we don't want decimal numbers. We want whole numbers. Okay, so our answer to number 24 is 4. Now, last one. Woo! Finally. All right, so if you've done all these problems, which means you've done 50 problems in 1 week. So that averages about 10 problems a day. So if you did all of this work, congratulations, you guys. You guys have made it to the end. Now you're ready to start this week, which only has 25. Okay, so that's good. That's good for you. All right, 25 is reasonable. I think this first week was just to get you back into practice. I know it's been a couple weeks for some of you guys since you've done math, so it's important that we're staying on top of these things. All right, so Jacob is working on his math homework. He decides the sum of the expression right here must be rational because it is a fraction. Is Jacob correct? Okay, so let's split these up here. Let's talk about these two pieces. Okay, so let's talk about 1/3. 1/3 is a rational number. Right? If you typed in 1/3, right, you would get 0.33333. Okay, it's rational because the 3 is being repeated and it continues on. Okay, so 1/3 is a rational number. So we have a rational number plus. Now let's take a look at 6 square root 5 over 7, which is clearly a fraction, right? But you got to be careful with these, right? So let's take a look. This is going to be, so if I were to split this up, whoops. Okay, all I did was just kind of separate those two fractions. Okay? All right, so I just kind of separated the denominator and brought it out to the right. Now we have 6 square root 5 over 1 times 1 over 7. All right, I didn't change the value of anything. Now, I want you to take a look at this piece. Okay? So I got square root 6, or 6 times square root 5 times 1 over 7, right? let's take a look at this. 6 times the square root of 5 is an irrational number. Okay, we've discussed this before. We got a rational times an irrational, which means we get an irrational number. So we got irrational times 1 over 7, which is a rational number. But again, we got a rational times an irrational. So this number right here is an irrational number. Okay, even though it is written as a fraction, okay, because we have that radical in there, it is still considered an irrational number. So now we have a rational plus an irrational. Remember our rules, rational plus an irrational number is always irrational. Okay? All right. And so that wraps up your number types and properties for week 1. So anyway, sorry this video is so long. I just felt like kind of chugging through it here. So anyway, hopefully you guys are keeping up with your studies. I'll send out this answer key for everybody, and you know, hopefully you guys are doing okay. I mean, it's important you guys are keeping up with your studies, but it's also important that you guys are finding ways to keep yourselves, you know, keeping yourselves happy, keeping yourselves healthy. Those are important as well, guys. All right, so don't stress over so much of the work here. Okay, the work will come. Let's just make sure that you guys are staying healthy, okay, staying occupied, doing something to keep you guys from, well, going insane or driving your parents insane. All right, so it's important that you guys, like I keep saying, build some sort of routine. Give yourself some sort of jobs during the day, okay? Set some time away for your studies, but then also set time away to do something, you know, to take your mind off the studies for a second. You know what I mean? Don't just be waking up, doing homework, and then going to bed, okay? Make sure you set time away for, you know, spend time with your family. Spend time with, well, I wouldn't say spend time with your friends, because make sure you're social distancing, okay? But just make sure you use this time to kind of, you know, find something that keeps you occupied other than, you know, I don't know, doing what you guys used to be doing. So I know it's tough, guys, you know, being cooped up. Just be patient, okay? Summer's coming, right? And this, everybody's doing what they're supposed to be. Everybody's social distancing themselves. This will be over, you know, hopefully sooner than later. So I don't have all the answers for that. Again, I'm just rambling. So if you guys are still listening, thank you. If not, too bad. So that being said, I'll be sending out the answer key this afternoon. Any questions you guys have, please email me. Email Ms. Costello. Email Mrs. Hellier. Okay. This is all new to everybody. Right? We're all trying to, you know, try to set up some sort of distance learning here. So this is kind of like the beginning step. So any sort of feedback you guys give on whether or not this stuff is helpful, what we can do, what we can't do or shouldn't do, or, you know, any sort of notes you can help us as teachers would not only benefit us, but only benefit you guys.